Our entire solar system in 1 hour. Why is the sun green and Mars blue? Human eyes see only visible light. Visible light comprises all the rainbow colors, sometimes labeled red, orange, yellow, green, blue, and violet, which, when combined, look white to our eyes. But there are many other invisible forms of light, i.e., the electromagnetic spectrum. Radio, microwaves, infrared, ultraviolet, X-rays, and gamma rays. The wavelengths of the various parts of the electromagnetic spectrum differentiate them. Radio wavelengths can span kilometers, while gamma ray wavelengths are smaller than atoms. Scientists design many instruments to detect infrared, ultraviolet, X-ray, or other wavelengths. These invisible forms of light have no associated colors. So, scientists have their computers assign unusual colors, like neon orange, to their images to allow them to observe details. Above left, scientists have captured a photo of the sun in extreme ultraviolet light, which our eyes cannot detect. The scientists have artificially dyed the ultraviolet data green. We call that false color. Scientific research and discoveries often challenge our perceptions. For instance, scientists have color-coded the image of Mars on the right to show the methane concentration in the planet's atmosphere. Scientists have marked the highest concentrations of methane in red and the lowest in blue, offering us valuable insights. Many of the images in this collection are likewise false-colored, a technique that helps us understand complex data. We have tried highlighting which images come from visible light and which represent false color or color-coded data, showcasing the importance of these scientific tools and methods. Our sun, the source of life. The sun, our very own star, reigns at the heart of our solar system. Scientists classify our sun as a yellow dwarf due to its position on the HR diagram, yet it defies this classification. The human eye perceives it as white, revealing a yellow or orange hue only when Earth's atmosphere scatters its rays during sunrise and sunset. It is now believed to be brighter and larger than approximately 85% of the stars in the Milky Way galaxy, most of which are red dwarfs. The sun's mass accounts for about 99.86% of the solar system's total mass, underscoring its immense significance and inspiring a sense of awe and respect. The sun consists of hot plasma, a state of matter where electrons have been stripped from their atoms, interwoven with magnetic fields. It has a diameter of about 109 times that. Earth's size is so great that 1,000,000 Earths could fit inside it. Its mass accounts for about 99.86% of the solar system's total mass. About 3/4 of the sun is hydrogen, the rest is mostly helium. Less than 2% comprises heavier elements, including oxygen, carbon, gold, iron, etc. Supernova explosions originally forged many of these elements. Therefore, star stuff comprises us and everything else in our solar system. Every second in its core, the sun converts 614 million metric tons of hydrogen into 609 metric tons of helium. The sun converts the difference into gamma rays, which eventually radiate at the solar surface as lower energy photons, primarily visible light. The hot atmosphere, called the corona, continuously expands in space, creating the solar wind, a stream of charged particles that extends beyond the solar system. The solar wind forms the heliosphere, a bubble in the interstellar medium, the largest continuous structure in the solar system. Solar activity. Our sun is a dynamic, active, and constantly changing star. Intense magnetic fields, generated deep within the solar interior and buoyantly rising up through its surface, drive solar activity. Plasma caught in the magnetic field lines allows us to see these fields. Sunspots are temporary regions of reduced surface temperature caused by increased magnetic activity. The sun goes through a cycle of about 11 years, during which it has a period of many sunspots, solar maximum, and then few or no sunspots, solar minimum. Sunspots or similar magnetically active regions are the source of solar storms. The sun's magnetic fields are constantly in motion. When solar magnetic fields twist, break, and reconnect, they can release tremendous energy. We see these as solar flares, like the white brightening near the center of the image on the right. Solar flares eject radiation and fast-moving particles that can damage satellites, disrupt communications, and give high-flying planes and astronauts additional doses of radiation. Finding ways to protect astronauts from solar flares is one of the biggest challenges of returning to the Moon or Mars. Sometimes, prominences erupt into coronal mass ejections, CMEs, as in the image on the right. These huge blasts of charged plasma traveling at 1400 kilometres can impact solar system objects. Luckily, Earth's magnetic field is a shield, partially protecting us. However, CME impacts on Earth still generate effects such as aurora, satellite drag, power outages, communications disruptions, and GPS interference. Space weather refers to the sun's effect on Earth and the rest of the solar system. The solar wind is a fairly constant stream of charged particles, mostly high-energy electrons and protons, ejected from the sun's upper atmosphere. These particles can escape the sun's gravity because of their high kinetic energy and the corona's high temperature. Radiation storms and CMEs have the potential to seriously affect Earth's modern technology. Besides triggering beautiful aurorae, these solar storms can damage satellites, disrupt power grids and electrical systems, interfere with cell phones and other communications, and disturb animal movements. They can even threaten astronauts and high-flying aeroplanes with their radiation. Space weather affects not only Earth, but also other planets. Our Sun formed in a gas and dust nebula about 4.5 billion years ago. After shining for another 5 billion years, it will expand into a red giant, eventually releasing its remaining gas and spending the remaining years as a dwindling white dwarf. Mercury, land of craters. Mercury is extreme. Of all the planets in our solar system, it is the smallest, has the oldest surface, is closest to the Sun, has the largest daily variations in surface temperature, and, until recently, was the least explored. All that has changed with the insertion of NASA's Mercury surface, space environment, geochemistry, and ranging MESSENGER spacecraft into Mercury orbit in March 2011. It has revealed rocky Mercury's geologic history, the nature of its weak magnetic field, the structure of its core, and the composition of its thin exosphere. MESSENGER has even discovered traces of water at Mercury's dark poles. What is the source of the radiating streaks in the image on the left? The impact crater, named for Japanese artist Katsushika Hokusai, is visible at the top of the frame. Its impressive ray system extends as far as 1,000 kilometers. An impact excavates material below the surface and explodes it outward from the crater, forming rays. Exposure to the harsh space environment causes rays like these to fade over time. Therefore, craters with bright rays are relatively young. This enhanced color mosaic shows the features of the sprawling Caloris Basin, one of the solar system's largest impact basins. The impact of a large asteroid-sized body during the solar system's early history created the basin, which spans about 1,500 kilometers and is visible in yellowish hues. The image data is from the January 14th flyby of the MESSENGER spacecraft. Orange splotches around the basin's perimeter are now considered volcanic vents, new evidence that Mercury's smooth plains are indeed lava flows. Scientists often add false colors to images to help them see finer detail. Note how much easier it is to study this image than the ones on the previous page. The image below shows Mercury's transit, crossing, before the Sun's November 8, 2006 disk. Mercury is about 57 million kilometers away from the Sun. Mercury details: diameter 4879 km, rotational period 59 days, distance from the Sun 57,910,000 km, 0.4 AU, orbital period 88 days, number of moons 0, atmosphere tenuous, temperature 160 degrees Celsius to 430 degrees Celsius, 0.004 degrees of axial tilt. Mass, 3.30 x 1023 kilojoules. About 5% of Earth's magnetic field. Venus. Heaven or hell? Venus, the second planet from the Sun, has roughly the same size, mass, density, and composition as Earth. In the 1960s, scientists and science fiction writers speculated that Venus might be Earth-like and home to lush, tropical forests. That view changed when new observations confirmed a superheated surface with temperatures over 400 degrees C and atmospheric pressures nearly 100 times that of Earth-Earth, the biggest difference from Earth-Earth within Venus's atmosphere. The clouds on Venus, which hide its surface, are not made of water like on Earth, which contains concentrated sulfuric acid, essentially battery acid. About 700 million years ago, just before life was diversifying on Earth, Venus experienced tremendous volcanic activity, flooding the surface with new lava and filling the atmosphere with greenhouse gases, causing a runaway greenhouse effect. Volcanoes continue to erupt on Venus. Only radar can probe through the thick clouds in the Venusian atmosphere to observe the surface. Radar data collected over many years from multiple sources created the beautiful, color-coded portrait of Venus's surface above right. In May 1989, the space shuttle at NASA launched the Magellan spacecraft from Venus. It started mapping the planet's surface in September 1990. Radio contact with the spacecraft ended the operation on October 12, 1994, during its controlled descent into the deeper portions of the Venusian atmosphere. Was there life on Venus? There is evidence that when it was young, Venus almost certainly had liquid water, an essential ingredient for life on Earth. Was Venus habitable in the past? Is it habitable now? Finding evidence of past life will be a big challenge, as massive volcanic activity caused 80% of the planet to resurface within the last billion years. However, if we ever recover samples from the ancient surface of Venus, they could provide significant insights. As for life on Venus now, some scientists speculate that single-celled organisms could actually survive within the harsh yet stable atmosphere, living off the sulfur chemistry there. Venus details. Diameter, 12,104 kilometers. The rotational period is 243 days, clockwise. Distance from the Sun, 108,200,000 km, 7.7 AU. Orbital period, 225 days. Number of moons, 0. Atmosphere, thick sulfuric clouds. Temperature, 480 C degree. Axial tilt, 177 degrees, retrograde. Mass, 4.268 x 2124. About 82% of Earth's seismic field, nearly none. Earth. You are here. In December 1968, the Apollo 8 crew flew back from Earth-Moon. A Saturn V rocket launched Frank Borman, James Lovell, and William Anders, who circled the Moon 10 times in their command module before returning to Earth in December. 1. As the Apollo 8 command module rounded the Moon's far side, the crew could look towards the lunar horizon and see Earth rising. The famous picture below left shows a distant blue Earth above the Moon's limb, a marvelous gift to the world. For those who have seen them, the Aurora Borealis and Aurora Australis are spectacles to remember. Currents of energetically charged particles in Earth's densification flow through the upper atmosphere, causing aurorae. The interaction between Earth's atmosphere and the solar wind drives these currents. The more particles flow to Earth's magnetic poles, the more active the Sun is, especially during its 11-year solar cycle peak. These charged particles eventually collide with molecules in the upper atmosphere, causing them to ionize, lose electrons, and emit colored light. Earth's thin atmosphere is all that stands between Earth's Earth and the cold, dark void of space. Our planet's atmosphere has no clearly defined upper boundary but gradually thins into space. The layers of the atmosphere have different characteristics, such as protective ozone in the stratosphere and weather in the lowermost planet's atmosphere. In 2008, Earth's crew on the International Space Station captured this image of the setting sun passing through Earth's atmosphere. Earth details. Diameter, 12,740 kilometers. Rotational period, 24 hours. The distance from Earth is 14 kilometers, 1.0 AU. Orbital period, 365 days. Number moons. 1. Atmosphere, nitrogen, oxygen. Temperature, 89 degrees to 70 degrees. Axial tilt, 23.4 degrees. Mass, or 6x 10,024 kilo. Yes, a magnetic field. Earth's moon. One small step for men, one giant leap for humanity. There is only one world in our solar system besides Earth on which humans have walked, the moon. Astronauts captured the image above on the moon during Apollo Earth's mission in December 1972. The image shows astronaut Harrison Schmitt getting ready to collect a soil sample. The later Apollo missions, including 17, had a strong scientific focus. Humanity left the moon a few days after taking this image and has yet to return. Note the sun in the upper left. It is daytime on the moon, but the sky remains black, with no air to scatter the light. Virtually everyone can see the moon, no matter where the Earth is. Most people know that the moon's gravitational pull on the Earth causes ocean tides. But did you know that missions to the moon have discovered the existence of moonquakes and water ice hidden in the permanently shadowed craters at the lunar moon? Apollo astronauts brought back lunar samples that shed new light on the moon's formation, suggesting that a rocky impactor the size of Mars struck the young Earth 3.5 billion years ago. That collision scattered debris, which orbited the Earth's orbit for about a month before coalescing into the moon. Around 3.9 billion years ago, a heavy bombardment of asteroids struck the moon again, causing much of the cratering we see today. The dark blotches on the moon's Earth-facing side are lunar mares, essentially large, dark basalt plains formed by volcanic eruptions. Why does the moon have a reddish hue in these lunar eclipse images? The same reason the sun appears reddish during a sunset: scattered light. During a lunar eclipse, the Earth sits earthly between the sun and the moon. The only sunlight reaching the moon travels through dense layers of the Earth's surface. Atmospheric particles preferentially scatter out shorter, bluer wavelengths, leaving only the longer, redder wavelengths to refract, bend through the atmosphere and illuminate the moon. Meteors and impacts. On Earth's surface, a Geminid meteor is one of the largest meteor fireballs ever recorded. Debris boils off a comet when it passes close to the sun, causing most meteor showers. When Earth passes through the debris, these specks may enter our atmosphere, causing us to see a meteor shower. Though most particles that cause our brilliant meteors are about the size of a grain of sand, the Geminids differ. Their meteor source is not a comet, but a strange rocky object that is considered an asteroid or an extinct or dormant comet. Meteors larger than a grain of sand, often chunks from asteroids, can sometimes reach the Earth's surface, as did the rock in the left image below. This one landed in the Sudan desert. Large meteorites can leave impact craters when they reach the ground. Mars, the red planet. Mars has been the subject of intense study for centuries. Success and failure have marked its exploration, leading to a dramatic evolution in knowledge. Images returned from NASA's Mariner 4 mission in 1965 finally put to rest speculations about Mars's famous irrigation canals in the late 1800s. They revealed icy deserts, impact craters, and a barren landscape, dispelling thoughts of thriving agricultural civilizations. In the 1970s, NASA's Viking mission carried out life detection experiments on the surface. The results, suggesting a lifeless planet, raised more questions than answers. Several spacecraft from the US, Japan, Europe, and the former USSR lost their lives during the next 2 decades. Success resurfaced in the late 1990s with the ESA orbiter Mars Express, NASA's Pathfinder rover, Global Surveyor, and Odyssey orbiters, heralding the mantra, "Follow the water." In 2004, NASA's twin rovers, Spirit and Opportunity, began work. NASA's Mars Reconnaissance Orbiter, and Phoenix lander followed. As the data from these robotic explorers piled up, so did the evidence that Mars preserves a record of surface liquid water and possibly once habitable environments. NASA's Mars Science Laboratory, which arrived in 2012, carried an unprecedented suite of instruments that can bring us one step closer to determining whether life ever started on Mars. Its Curiosity rover is now offering a human-like perspective on Mars landscapes. ESA's Mars Express obtained this view of an unnamed impact crater on Vastitas Borealis, a broad plain covering much of Mars's far northern latitudes. Residual water ice makes up the circular patch of bright material. Although the colors closely resemble natural ones, the vertical relief has undergone 3 exaggerations. This patch of ice is present all year, remaining after frozen carbon dioxide overlaying it disappears during the Martian summer. NASA's Mars Reconnaissance Orbiter spacecraft captured this breathtaking image of Victoria Crater, an impact crater near Mars' equator, where hematite mineral deposits suggest Mars had a wet past. The crater's inner wall exposes layered sedimentary rocks, while a striking field of sand dunes occupies the crater's floor. Since 2004, NASA's twin Mars exploration rovers, Spirit and Opportunity, have been exploring the surface of Mars to uncover the history of water on the red planet, despite Spirit's unfortunate deactivation. In September 2006, the Opportunity rover arrived at the rim of Victoria Crater after a journey of over 9 kilometres, 5 days before this image. It explored within the crater, staying at the site for about a year. This image shows the rover as a small dot at the 10 o'clock position along the crater rim. Chasma Boreal, pictured above, is a long valley that cuts deep into Mars's north polar ice cap. Sand from earlier, less icy climatic regimes exposes where the ice cap has retreated. Winds have shaped them into dunes. In 2007, NASA's Phoenix mission landed in the northern Arctic plains of Mars to study the history of water and potential habitability in the ice-rich soil. Phoenix verified the presence of water ice in the Martian subsurface and found calcium carbonate, an indicator of a less acidic, more potentially habitable planet in the past. Phoenix even observed snow falling from clouds in the Martian atmosphere. NASA's Mars Odyssey and Global Surveyor orbiters combined data to create this eerily Earth-like vista. The intriguing image on the left depicts the Nili Foci region of Mars, which occupies an area between a large volcano and an ancient impact basin. It contains a collection of curved troughs that cut about 500 meters into the crust. The Mars Express, a European spacecraft, detected clay minerals there, which is good news for astrobiologists because the clays suggest the presence of water at some point. Even better, the minerals suggest that the surface pools of water provide a comfortable habitat for life. Some time ago, scientists discovered signs of water on Mars, but they needed to understand its mineral composition. Recent findings indicate that water covered a significant portion of the planet approximately 4 billion years ago. Astrobiologists have also detected the presence of methane gas in Mars's atmosphere, indicating that the planet is indeed alive, either in a geologic or biologic sense. The production of methane by purely geologic processes, like iron oxidation or microscopic organisms living in the Martian subsurface, remains unclear. Finding plumes that persist only during Martian spring and summer indicates that some ongoing, seasonal process releases the gas. Methane-producing microbes were one of the earliest forms of life on Earth, so there is life on Mars today. It could make methane from carbon dioxide in the Martian atmosphere. This sunset may look familiar, but it is not from Earth. On Earth, the rover Spirit captured this lovely, otherworldly evening as it peered towards the western sky from its perch in Gusev Crater on Mars. Like no other spacecraft, the Mars exploration rovers have afforded us a perspective much like our own on another world, making Mars feel more like home. Mars details: diameter 6,780 km, rotational period 24.7 HRs, distance from the Sun 227,900,000 kilometers, 1.5 AU, Orbital period, 687 days. Number moons, 2. Atmosphere, thin carbon dioxide. Temperature, 143 degrees to 27 degrees. 25 degrees of axial tilt. Mass, 6.4 x 1023 kilometers, about 10% of Earth's. Earth's field, virtually none. Phobos, one of Mars's 2 moons, faces certain doom. Phobos orbits very close to Mars, and the strong gravitational, i.e., tidal, forces are taking their toll. These relentless tidal forces will likely cause Phobos to shatter in about 100 million years due to the stress they cause. The debris may form a ring around Mars. Deimos, named for the Greek word flight or panic and looking potato-like on the right, is Mars's smaller, Gasimon 12-kilometer outer moon. Both moons are likely captured asteroids originating in the main asteroid belt between Mars and Jupiter, or perhaps from even more distant reaches of the solar system. Asteroid belt. Millions of asteroids vary in diameter, from dust particles to 950 kilometers. Like most other small solar system bodies, asteroids are believed to be the shattered remnants of planetesimals, bodies within the young sun's solar nebula that never grew large enough to become planets. In the main asteroid belt, the most well-known asteroids orbit between Mars and Jupiter, or co-orbital with Jupiter. However, other orbital families exist with significant populations, including the near-Earth asteroids. In the image above, Ida and Gaspra, superimposed with each other, are 2 such rocky metallic objects. On the same scale, Ida is about 30 kilometers long, and Gaspra is about 17 kilometers. Asteroids have contributed to the evolution of life on Earth. Sometimes, asteroids' orbits bring them close to Earth, and earthquakes ensue. There is strong evidence that an asteroid at least 12 km wide caused the mass extinction that killed the dinosaurs 66 million years ago. If that had not happened, would humans be walking the Earth today? In the inner solar system, Earth is the largest asteroid and the only dwarf planet. It is a rocky, icy body only about 950 kilometers in diameter, though it contains about 1/3 of the asteroid belt's mass. Giuseppe Piazzi discovered Ceres in 1801. Initially, scientists classified Ceres as a planet. Scientists realized that Ceres represented the first of a class of similar small bodies as they discovered other objects in the area. Launched on September 27, 2007, NASA's uncrewed Dawn spacecraft set out to explore and study Vesta and Ceres, the most massive objects in the asteroid belt. The probe entered orbit around Vesta on July 16, 2011, and left Vesta on September 5, 2012, on a course for Ceres, which started orbiting in March 2015. Asteroid Itokawa shows features common to many asteroids, indications of pieces from previous asteroid collisions formed when gravity pulled the small bits together. Note the lack of impact craters and the rough surface studded with boulders. Jupiter, king of the planets. Jupiter, the most massive planet in our solar system, forms a miniature solar system with 79 known moons and an enormous magnetic field, magnetosphere. Gaseous Jupiter resembles a star in composition, but it never grew massive enough to start the fusion process. Astronomers are searching for life elsewhere in the solar system. Jupiter's Great Red Spot, a vast cyclone located in Jupiter's southern hemisphere, is about 3 times the diameter of Earth and Earth-Cybele, even with small backyard telescopes. Different chemicals and gases churn up from the bottom layers to the surface of the gaseous planet, causing the colors to change. The winds at the spot's edge can reach up to 550 km per hour. Astronomer Giovanni Cassini first observed this long-lasting storm in the late 1600s. NASA's Pioneer 10 spacecraft observed it up close in 1974. In this image, everything visible is a cloud. Jupiter's clouds, like Earth's, consist of ammonia, hydrogen sulfide, and water, where earthly water condenses to form clouds. Jupiter's many jet streams shear clouds apart, forming characteristic streaks. At 480 km per hour, the fastest jet stream winds blow eastward. The small, bright clouds to the left of the Great Red Spot are the most energetic features. They grow and disappear over a few days, generating lightning. Jupiter details. Diameter: 139,122 km. Rotational period: 9.8 years. In distance from the Sun: 778,500,000 kilometers, 5.2 AU. Orbital period: 11.9 years. There are 63 moons. Atmosphere: hydrogen, helium. Temperature: 140 degrees. Axial tilt: 3 degrees. Mass: 1.9 1027 kilo. About 318 Earths. Strong and complex magnetic field. Jupiter's 79 moons, including Io, Europa, Ganymede, and Callisto. Galileo discovered Jupiter's 4 largest moons in 1610, using the newly invented telescope to view our night sky. His sketches on the right show how the orbiting moons appeared on subsequent days. Io. This image shows Io, the closest of Jupiter's moons, and one of the most interesting. About the size of Earth's moon, Io is the most volcanically active body in the solar system. Io's volcanoes erupt massive volumes of silicate lava, sulfur, and sulfur dioxide hundreds of kilometers above the surface, constantly changing Io's appearance. The bumpy areas on the surface, called padari, often line up with active volcanoes. Their numerous straight lines and sharp angles indicate their connection to the cracks in Io's crust. Lava often erupts from these irregular depressions. Io's intense volcanism results from frictional heating of its interior due to bending and curving, caused by the gravitational pull of Jupiter. Europa. Above are 2 views of Jupiter's icy moon Europa, which is about the size of Earth's moon. The left side shows the approximate natural color appearance, while a false color composite, including infrared data, is on the right. The dark brown areas represent the salty material that originates from the interior. Fractures in the crust are long, dark lines, some more than 3,000 kilometers long. Habitat for life? Europa excites astrobiologists because of its potential to host life in the 100-kilometer-thick liquid water ocean that scientists think exists beneath its icy exterior. Numerous volcanoes dot Europa, and researchers have discovered ecosystems flourishing near volcanoes, hydrothermal vents on Earth's surface, serving as analogues to potential life on Europa. A 20-kilometer-thick ice shell covers Europa's ocean, forming the moon's outer surface. Jupiter's gravitational pull raises and lowers the sea beneath the ice, causing extreme tides. These keep Europa's icy surface in motion and are likely responsible for the cracks and streaks. Scientists believe that the gravitational pull influencing ocean tides also heats Europa's core, preventing the water from freezing completely and promoting geological activity. With both liquid water and a stable source of energy present, it is no wonder astrobiologists think Europa could be a habitat for extraterrestrial life. Ganymede. Ganymede is the largest moon in the solar system, 8% larger than Mercury. It comprises about equal amounts of silicate. The material consists of rock and water ice, with a liquid core rich in iron. A saltwater ocean is believed to exist nearly everywhere, 200 kilometers below Ganymede's surface, sandwiched between layers of ice. The satellite has the thin oxygen atmosphere contains O2, and possibly O3, ozone. 2 main types of terrain compose Ganymede's surface. Dark regions, saturated with impact craters and dated to 4 billion years ago, cover about a third of the satellite. Lighter regions cover the remainder, cross-cut by extensive grooves and ridges that are only slightly less ancient. We must fully understand the cause of the disrupted geology in the light terrain, but tectonic activity likely resulted from Jupiter's gravitational forces, specifically tidal heating. Ganymede is the only satellite in the solar system known to possess a magnetosphere, a protective magnetic shield, likely created through convection within the liquid iron core. Jupiter's much larger magnetic field buries the meager magnetosphere. Open field lines connect the satellite to the field. The question of whether the satellite has an ionosphere associated with its atmosphere is still unresolved. Callisto. Callisto, about the size of Mercury, has the most heavily cratered and oldest surface in the solar system. NASA's Galileo mission, 1989 to 2003, observed Callisto, revealing evidence for a subsurface saltwater ocean. The same evidence for the ocean scientists think exists on Europa. Can life emerge and thrive in such cold, lightless oceans? If there's life in one of these two oceans, it is more likely to be Europa's. Because Europa has a stronger gravitational relationship with Jupiter, the ocean there receives more heat. Callisto's ocean, if it exists, is so deep that dense, high-pressure phases of ice will form at the ocean bottom, possibly blocking liquid water and rock from interacting directly to create conditions for life. Saturn, ring world. Gaseous Saturn is the second largest planet in the solar system, behind Jupiter. Despite their imposing appearance, the glorious rings around Saturn are only about 10 meters thick. The rings consist of billions of individual particles, mostly water ice. Interactions with the gravitational field of Saturn's moons create waves, wakes, and other structures. Tiny moons orbit within the ring's gaps, keeping them open. Scientists still need to pinpoint the ring's exact age and formation process. However, the creation of each ring we see today is unique. NASA's Cassini mission discovered that a great plume of icy material emanating from Saturn's moon Enceladus is a major source of material for the expansive E-ring. Cassini has also discovered new ringlets, a moon stealing particles from the narrow F-ring, and features within the rings shaped like straw and rope. Saturn, though far from the Sun, is still subject to the Sun's storms. NASA's Cassini spacecraft constructed this false color composite image, which shows the glow of aurorae, streaking out about 1,000 kilometers from the cloud tops of Saturn's south polar region. As shown in green, the aurorae occur when energetic, charged particles from the Sun, carried by the solar wind, interact with Saturn's magnetic field. Clouds and small storms cover Saturn's deeper weather systems and circulation patterns, forming dark spots and banded features. NASA's Cassini spacecraft captured this image of Saturn's stunning ring system, glowing with scattered sunlight, as it passed behind the planet in 2006. This image also shows the Earth, the barely visible white dot between the bright main rings and the thinner, light brown ring at 10 o'clock. Saturn details: diameter 116,464 kilometers. Rotational period 11 Inertia distance from the Sun 1,433,000 kilometers 9.5 AU. Orbital period 29.5 years. Number of moons 62 plus. Atmosphere hydrogen, helium. Temperature 178 C. Axial tilt 27 degrees. Mass 5.7 x 26 kg. About the same as Earth. An arthritic field similar to Earth's. Say Earth's 82 moons, including Titan, Enceladus, Iapetus, Hyperion, and Phoebe. Saturn has at least 62 moons, ranging from just under 3 kilometers to about 5,000 kilometers. Two of the moons, Titan and Enceladus, are of great interest to astrobiologists. Titan provides an analog to the chemistry of early Earth. An Earth lattice's inner heat and jets of ice and water vapor could be a habitat for extraterrestrial life. Titan and Tethys. Titan is the largest of the moons orbiting Saturn. Until recently, Titan appeared as a hazy orange sphere in our view. NASA's Cassini mission changed all that. Cassini and the Huygens probe launched into Titan's surface, relaying data about the atmosphere and weather it encountered on Earth. The earthly world, see images below, looked a lot like home, with surface features like riverbeds, vast deserts covered in dunes, and even lakes filled, not with water but with liquid hydrocarbons, much like the fuel we put into our cars. These lakes are the first open liquid bodies found anywhere besides Earth. The Earth portrait also shows one of Saturn's smaller moons, Tethys. It is believed that Tethys primarily consists of water and ice. Odysseus crater, a giant impact crater 2/5 the diameter of Tethys itself, dominates its surface. NASA's Cassini spacecraft peered through Titan's atmosphere to obtain its surface's false color views. Above, despite its distance from the Sun, Titan is arguably one of the most Earth-like worlds we have found. With its thick atmosphere and complex carbon-rich chemistry, Titan resembles a frozen version of Earth several years ago, before life began pumping oxygen into our atmosphere. Titan's surface is formed by rivers and lakes filled with liquid ethane and methane form clouds and occasionally rain down from the sky, much like water does on Earth. Earth Alpt has vast regions of dark dunes that girdle the equator and low latitudes. Volcanism may also occur with liquid water lava instead of molten rock lava, like on Earth. Earths. Close flybys of NASA's Cassini spacecraft revealed an array of narrow linear cracks straddling Enceladus's south pole, a region of relatively higher temperature. The tiger stripes are visible in the false color composite image on the left. There are fissures on the surface where jets spray icy particles, water vapor, and organic compounds. Many jets erupt all along the tiger stripes, and the vigor of individual jets can vary with time. Some scientists think that the warmer the temperatures at the surface, the greater the likelihood that jets erupt from the liquid. If true, could this liquid subsurface? Can an environment rich in organic molecules serve as a potential habitat for extraterrestrial life? The image above right shows, in spectacular false color, a view of jets on the surface of Enceladus, spurting their ice particles, water vapor, and trace organic molecules into space. Iapetus. People have dubbed Iapetus the yin and yang of Saturn's moons due to the dark, coal-like reflective surface of one hemisphere and the much brighter surface of the other. The original dark material is believed to have come from outside Iapetus, but now it consists of lag from the sublimation of ice from the warmer areas of Iapetus's surface. It contains organic compounds similar to those found in primitive meteorites or on the surface of comets. The image above shows a massive impact crater spanning 450 kilometers south. An older crater of similar size appears to be overlaid. The previously mentioned dark material gradually covers the easternmost part of Iapetus, darkening craters and highlands. Close inspection indicates that the dark coating typically faces the moon's equator and is less than a meter thick. One leading hypothesis suggests that the dark material primarily consists of dirt, resulting from the sublimation of relatively warm but dirty ice. The accretion of meteor-liberated debris from other moons may have effectively applied an initial coating of dark material. The image above right shows a prominent feature of Iapetus, an equatorial ridge that runs along the center of Cassini Regio. In 2004, the Cassini spacecraft imaged and discovered Iapetus. Peaks in the ridge rise more than 20 kilometers above the surrounding plains, making them some of the tallest mountains in the solar system. Hyperion, sponge or moon. Scientists have enhanced this stunning image of Hyperion to reveal crisp details across the strange, tumbling moon's surface. Scientists attribute Hyperion's somewhat potato-shaped appearance to its unusually low density for such a large object, resulting in weak surface gravity and high porosity. Hyperion's craters are particularly deep, and landslides appear inside many larger ones. The result is a curious look, like the surface of a sponge or a wasp nest. Many of the crater walls on Hyperion are bright, suggesting an abundance of water ice. Phoebe. Phoebe's orbit around Saturn is in the opposite direction from the orbits of most objects in the solar system. This suggests Saturn's gravitational pull captured Phoebe and brought her into orbit. Scientists think Phoebe might have been part of an ancestral population of small, icy bodies called centaurs, which originated in the outer solar system but migrated inward. Centaurs are of special interest to scientists because they are considered primordial objects, leftovers of solar system formation that never coalesced into a planet. If it is a captured centaur, then images and scientific data of Phoebe, taken by NASA's Cassini spacecraft, give scientists the first opportunity to study a centaur. Uranus, god of the sky. Astronomer William Herschel discovered Uranus, the third largest planet in our solar system, in 1781. It shares its name with the Greek god of the sky. Most of what we know about Uranus comes from the NASA Voyager 2 spacecraft's flyby of the planet in 1986. Uranus has 9 major, though extremely faint, rings and 27 known moons. This gas giant, right, reveals cloud structures not normally visible to human eyes. Methane gas in the upper atmosphere absorbs red light, giving the planet its blue-green color. Uranus is spinning on its side, probably because of a collision with a large object early in the solar system's history. Uranus details. Diameter, 50,724 kilometers. The rotational period is 17 hours on its side. Distance from the Sun, 2,877,1,200 kilometers to 19 AU. Orbital period, 84 years. Number of moons, 27. Atmosphere, hydrogen, helium, and methane. Temperature, 224 C°. Axial tilt, 98 degrees. Mass, 8.68 x 1025 kilos, 14 times Earth. Magnetic field, strong dipole but offset. Uranus's 27 moons. Taking its first peek at Uranus, the NASA Hubble Space Telescope's near-infrared camera and multi-object spectrometer, NICMOS, took the images below 90 minutes apart. We assigned false colors to the images because the human eye cannot detect infrared light. The rings of Uranus are extremely faint in visible light, but quite prominent in the near-infrared. The epsilon ring, which is the brightest, has a variable width around its circumference. Its widest, and thus brightest part, is at the top of this image. 2 fainter inner rings are visible next to the epsilon ring. The images above show 8 of the 10 small Uranian satellites discovered by Voyager 2. Their sizes range from about 40 kilometers for Bianca to 150 kilometers for Puck. These 8 satellites revolve around Uranus in less than a day, the inner ones faster than the outer ones. The right panel marks their movements during the 90-minute interval between the 2 images. We slightly increased the brightness of the area outside the rings to improve the visibility of these faint satellites. Neptune, the mysterious cold world, dark, frigid, and whipped by supersonic winds, Neptune is the farthest away from the sun of our solar system's hydrogen and helium gas giants. Its thick atmosphere acts as a dark veil on the surface below. We know there are at least 14 moons and a faint ring system, and it takes almost 165 Earth years to orbit the Sun. Neptune's atmosphere extends to great depths, gradually merging with water and other melted ices over a heavier, approximately Earth-sized, solid core. In 1989, NASA's Voyager 2 spacecraft tracked a large, oval-shaped storm called the Great Dark Spot, similar to the Great Red Spot on Jupiter. NASA's Hubble Space Telescope failed to detect the Great Dark Spot during its 1994 planet image. Details. Diameter, 49,244 kilometers. Rotational period, in 16 hours, a distance from the Sun, 4,503,000 kilometers. 30 AU. Orbital period, 165 years. There are 13 moons. Atmosphere, hydrogen, helium, and methane. Temperature, 210 degrees. Axial tilt, 28 degrees. Mass, 1.0226 km, about 17 times Earth. In a magnetic field, the dipole field is located on the right. Angles to the rotation axis. Triton is one of Neptune's 14 moons. Triton. Triton is the largest of Neptune's 14 known moons. NASA's Voyager 2 spacecraft captured this stunning portrait in 1989 using a false color mosaic. Triton is one of only a few objects in the solar system known to have a nitrogen-dominated atmosphere. The others are Earth, Saturn's moon Titan, and Pluto. Its frozen surface is primarily nitrogen ice, with some methane ice at the South Pole. Voyager 2 observed active geyser-like plumes erupting from the surface, perhaps similar to Saturn's moon Enceladus. Triton orbits Neptune in the opposite direction from most objects in the solar system, like Phoebe's orbit around Saturn. This article discusses the Kuiper Belt, dwarf planets, and trans-Neptunian space. A dwarf planet is defined by the International Astronomical Union as a celestial body in direct orbit of the Sun that is massive enough for gravitation to control its shape, i.e., round. But unlike a planet, it has not cleared its orbital region of other objects. There may be hundreds or thousands of dwarf planets in the solar system. We have named 5: Ceres, Pluto, Haumea, Makemake, and Eris. Ceres resides in the asteroid belt. The remaining 4 are either part of the Kuiper Belt or trans-Neptunian objects. This includes Eris, Pluto, and 4 of its 5 moons. NASA. 4. An AU is approximately 150,000 km, the mean distance from Earth to Earth. Trans-Neptunian objects. A trans-Neptunian object, TNO, is any object in the solar system that orbits the Sun at a greater average distance than Neptune. This includes objects in the Oort cloud, more later, and the Kuiper Belt. Sedna is a large trans-Neptunian object, about 3 times as far away from the Sun as Neptune in 2012. Like other TNOs, its surface is largely a mixture of water, methane, and nitrogen ice, though it is also one of the reddest in the solar system. It is probably a dwarf planet. Sedna's exceptionally long and elongated orbit, which took approximately 11,400 years to complete, and the distant point of closest approach to the Sun, at 76 AU, have led some astronomers to conclude that it is the first known member of the inner Oort cloud. Comets. All image credits are Dan Schechter Takach, KISS, Uni, Sydney, and Szabo, Uni, Szeged. Collisions or the gravity of a passing star push most comets out of their orbits, originating from the Kuiper Belt. Without comets, would there be life on Earth? EVI-Earth shows that comets partially transported water and organic molecules, essential for life's formation, to the early Earth. What-earthed ice enriches comets. Studies of Comet Halley in 1986 revealed it to be some of the most organic-rich material ever measured in the solar system. NASA's 2004 Stardust mission to Comet Wild 2 found a range of complex hydrocarbon molecules, and NASA's 2005 Deep Impact mission to Comet Tempel 1 discovered a mixture of organic and clay particles. Scientists believe that comet impacts and deliveries were common in the early solar system, but they continue to debate whether comets incorporated Earth during its formation or as a result of cometary impacts after formation. To the left is a close-up of Comet Hartley 2. After encountering Comet Tempel 1 in 2005, NASA recycled its Deep Impact spacecraft and deployed it on a new mission, Epoxy, to investigate Comet Hartley 2. By comparing Epoxy observations with prior observations of other comets, NASA hopes to understand how comets form and evolve. The spacecraft made its closest approach with Hartley 2 on November 4, 2010. Preliminary observations show a very active comet. The main region of jet activity originates from the rough lobe on the sun-facing side of the nucleus. Subsurface carbon dioxide releases power, propelling water, ice, and dust into the coma, the comet's extremely tenuous atmosphere. Scientists can track the jets to individual topographic features on the comet's nucleus. Yet, as more observations arise, so do more questions. Interplanetary dust particles. Space is not void. Certainly, the smallest bodies in the solar system, interplanetary dust particles, or IDPs, are microscopic. Glass, carbon, and a conglomeration of silicate mineral grains, similar to beach sand, make up this one, above left, about 1/10 the width of a human hair. IDPs are bits of material from the early days of our solar system. A passing comet can capture them and subsequently eject them. An aircraft flying high in Earth's atmosphere collected this IDP. In 2004, NASA's Stardust mission passed through the tail of Comet Wild 2, collecting cometary particles and returning them to Earth. This primitive material provides scientists with a glimpse into the conditions of the early solar system. When large versions of these dust particles chance to enter Earth's atmosphere, they may appear as bright meteors. The Sun's heliosphere. The heliosphere is an immense magnetic bubble originating from the Sun. It surrounds and envelopes our solar system, blocking many of the dangerous cosmic rays from our galaxy. The solar wind depicts it as a bubble in space, blown into the interstellar medium, the hydrogen and helium gas that permeate the galaxy. Although electrically neutral atoms from the interstellar medium can penetrate this bubble, virtually all heliosphere material emanates from the Sun. The solar wind travels at over 1 million kilometers per hour for the first 10 billion kilometers of its radius. As it begins to drop out of the interstellar medium, it slows down before ceasing altogether. The termination shock is the point at which the solar wind slows down. After the termination shock, there is the heliosheath area. Then comes the point where the interstellar medium and solar wind pursues balance, the heliopause. The bow shock is the point at which the interstellar medium, traveling in the opposite direction, slows down as it collides with the heliosphere. For decades, it was thought that the heliosphere extended in a long, comet-like heliotail, but in 2009, data from Cassini and Ibex showed a different shape. The heliosheath area is not smooth, but it is filled with magnetic bubbles pushed out by the solar wind. Where are we? Our Milky Way galaxy is home to our solar system, Earth, a birth hole at its center, and 400 billion stars. Our solar system is located about 2/3 of the way out from the galaxy's center, on the inner edge of the Orion Arm. The Sun orbits the galaxy's center in a galactic year, once every 250 million Earth years. Scientists estimate that the Milky Way is home to at least 50 billion planets, 500 million of which may reside in the habitable zone of their parent star, in addition to stars. New data suggest there may be up to twice as many free-floating planets no longer attached to their stars, in the Milky Way as there are stars. Our Milky Way is one of around 200 billion galaxies in the observable universe, our immense universe. The Hubble ultra-deep field image below is of a tiny region of space in the constellation Fornax, composited from Hubble Space Telescope data accumulated from September 24, 2003 to January 16, 2004. It is the deepest image of the universe, looking back approximately 13 billion years, between 400 and 800 million years after the Big Bang. We took this image in an empty section of the sky with a low density of bright stars in the near field, enabling use to clearly view dimmer, more distant objects. The image contains an estimated 10,000 galaxies. Our Sun is only one of billions of stars in the Milky Way galaxy. The Milky Way is only one of the billions of galaxies in the universe. Do you think we are alone? In 1990, upon Carl Sagan's request, NASA commanded the Voyager 1 spacecraft, having completed its primary mission and now leaving the solar system, to turn its camera around to take a final photograph of Earth's largest expanse of space. This photograph of planet Earth from over 6 billion kilometers away is a pale blue dot, showing its contrast to the vastness of space.